Hello everyone. In this video, we'll be discussing about Numpy. Like any other data science libraries, Pandas, Matplotlib, sklearn, Numpy is also a Python library. It is the fundamental package for scientific computing. So, for you to get the quick introduction about Numpy, let me tell you, Numpy library is basically used to work with arrays. It has many mathematical functions to operate on the arrays and also has a support for large multidimensional array and matrices. For understanding Numpy, you should have basic knowledge about Python programming language. Also, for practicing the code, you should have installed Jupyter Notebook or any other editor which supports Python in your system. Before we start studying Numpy, let us first revise concepts of arrays and Python lists. Numpy is something which deals with arrays. So let's see it first. Array. An array is a collection of items stored at contiguous memory locations. The idea is to store multiple items of the same type together. It is one of the most common data structure you might have used in the competitive programming. So basically, array has two things, index and the value. Index start from 0 till n-1. As we can see in the picture, we have 5 elements, so our index will range from 0 to 4. Array can be one-dimensional or multi-dimensional. In one-dimensional array, we have this linear list of elements, that means only one row. In multi-dimensional array, we have multiple data elements of the same type and are stored in matrix or table-like format with number of rows and columns. Now, let's learn about Python lists. These are also kind of arrays. Here, data is enclosed inside square brackets and separated by commas. Unlike other programming languages, like Java or C++, in Python, we use lists instead of using arrays. Lists are mutable in nature. It means data can be changed whenever it is required. Python lists can store different data types within a single list. That means you can store integer and a string in the same list. It has many built-in functions, which makes it more easier and handy. So now you might be wondering, if the Python lists are this effective, then why to use Numpy arrays? So let me clear your doubt with few points. Numpy can provide an array object that is up to 50 times faster than traditional Python list. Isn't it cool? Numpy arrays also provide various mathematical functions which would make the data science task easier and quicker. Now let's quickly install the Numpy library. It's actually very easy. One line of command and you are good to go. If you have Python and pip installed on a system, then installation of Numpy is very easy. Install it using the command pip install numpy. Or if you are using Anaconda prompt, then you can use the command conda install numpy. Now, to use Numpy in our program, we need to import it. Like any other library you import, this is also same. Just go into your Jupyter Notebook and start typing import numpy as np. Here, np will be used to call Numpy library. Remember, there are no hard and fast rules and you can name it as you want. Now, let's start with creating Numpy arrays. To create a basic Numpy array, we can use the function .array. Here we can pass the values inside the square brackets and separate the values with commas. See, this is how I have created these two arrays. Okay, now let's suppose we have a Python list and we want to create a Numpy array from it. The only difference is, instead of passing the value in our .array function, I'll just pass that specific list into it and our list will get converted to Numpy array. In Numpy, we also have some built-in function by which we can create arrays. So we can create an array in which all the values will be 1. We simply have to call .ones function and pass the required number of elements here. As you can see, I have created an array of 5 ones and the output will be something like this. Similarly, we also have .zeros function to create an array of zeros. Also, if you want to create an array which should include all the values given in a particular range, then we can use this .range function and pass the range here. You can also define the step size here. Now comes the array with random numbers. Numpy provides facility to create an array with random numbers in the interval 0 to 1. You can use this function like this. So it was all about creating 1D array. Now let's move to n-dimensional array. We already have discussed multidimensional array earlier in this tutorial. Let's get to the code part. We are creating a 2D array. Here also we are using the same .array function, but instead of passing the values in the normal array, I am passing the values like a nested list. Just for the sake of understanding, 2D array would be like a list inside list. Here the main list will have sublist as its value. You can also see the output here. We can also use other functions like we used in 1D array by passing the dimensions. I guess you might have understood now. Now comes the interesting part, indexing and slicing. We can never deny how much indexing and slicing is useful to the coder. Indexing Numpy arrays is similar to that of Python list. You can simply pass the index you want. We have square brackets as the index operator and we can pass integer to these square brackets from 0 to n-1 to get the desired element. You can look at the example to understand this. We can also access last element of the array by passing -1 and similarly others. Suppose I want to access fourth last element of the array, then I will pass -4. Similarly, we can select elements in a 2D array using either the double bracket notation or the single bracket with comma notation. See here in this example, I have this 2D array and here I am passing row index in the column index of the element I want. And you can see the result. Now comes slicing. Slicing means to get the elements from one index from a given index to the another given index. You can put a colon or a combination of the column with an integer in it to designate the elements or rows or columns you want to select. We basically have 3 parameters, the starting index, ending index, and the step size, which is quite an optional thing. Now the trick is how to use this to get the required subarray. The first example is quite self-explanatory. Let's see the second one. We just have specified the step size. So if I choose step size equal to 2, my next element would be 2 steps ahead of the current element. Simple example of this is odd and even numbers which have step size 2. Remember, the ending index will not be included in your resultant subarray. Now, if I am specifying the starting index but not the ending index after the semicolon or before the semicolon, it means I want the subarray from the starting index till the end of the array and vice versa for the next example. Shape function will return the tuple of integers that indicate the number of elements stored along each dimension of the array. Endim function returns number of dimensions present in the array. Size function returns the total number of elements in the array. This is the example to understand this. Pause the video for a while and try run this thing in your mind to see if you are getting the same output. Now, just practice and use them as per your need. I hope it was an informative session. Keep exploring, learning, and practicing. Thank you for watching this video.